In case of two-dimensional or three-dimensional data, it appeared as if we can simply make a scatter plot and we can understand where does the principal component lie. However, if you want to be sure, you need to know the statistical procedure of obtaining the principal components. We are going to learn how to use SAS or R to get that. However, before using SAS and R, we need to understand how to supply the correct data. And we must ensure that the data that has gone as an input to principal component analysis is correct. For that reason, I am going to explain you how to deal with numeric and ordinal kind of data one by one. So let's first start with ordinal data. Ordinal variable must be converted into 0 to 1 scale. I am going to show you how. And numeric variable must be standardized. Unless the package supports correlation, most of these advanced packages like SAS and R supports correlation. However, if you have any doubt, you better standardize the variable. So let me explain you. In fact, I'm going to talk more about standardization also if you have any doubt, but let me talk about both of them one by one. So ordinal variable, how to deal with ordinal variable. Ordinal variable is variable where you have order, like very satisfied, somewhat satisfied, neutral, somewhat dissatisfied, very satisfied. If you look at, there is an order. Somewhat dissatisfied is little better than very dissatisfied. Neutral is in between. Somewhat satisfied is some little positive, and very satisfied is obviously much positive. But these are still not numbers. And I will suggest one should try to avoid this kind of data for principal component analysis. However, if data itself is predominantly of ordinal kind of variable, then you should convert into scale and then you should use it. Let me show you how you're going to use it. First of all, what you should do, you should rank them. So, and then you have to create derived variable like rank -1 to max rank -1. Let me show you an example that will give you little better understanding. So here you have very dissatisfied, somewhat dissatisfied. So we created a mapping like 1, 2, 3, 4, 5. In this, the max rank is 5, and so if you look at for this particular variable, what we are going to do, rank -1, so 1 -1 divided by max rank -1, max rank -1, 5 -1 will give you 4, 0 by 4 will give you 0, for 2, 2 -1 by 4, so essentially 1 by 4 is going to give you 0.25. So if you look at this whole data has come into the format of 0, 0.25, 0.5, 0.75, 0.1. Sorry, 1. So there is an intrinsic assumption that has been assumed that these are equally distant, and if at all you are dealing with ordinal variable, that's up to some extent it's a fair assumption. You have to apply the same procedure even if like there are many categories, like if you look at here, and let's say if there are categories like A to I, and it is as if like I is better, B is better than A, C is better than B, like that, then what you are doing, again the same thing, you ranked it 1 to 9 and rank -1 to max rank -1, that's what is giving you. So if you look at this, got converted between 0 to 1. So if you look at this procedure converts the number between 0 to 1. Now look at how to standardize numeric variable. Numeric variables, if they are in different scale, they can cause problem, like one particular variable itself can come into the principal component. So what is the right way? Right way is that you standardize it. Standardization means what? Standardization means like you actually minus the mean and divide by the standard deviation of the data. And I will suggest you that you should do it for all the variable, including converted ordinal variable. In fact, ordinal variables are anywhere between 0 to 1, and if you are just dealing with ordinal variables only, then you can leave it like that. However, if your data has ordinal plus numeric variable, in that case I will recommend you to convert even converted ordinal variable which has come between scale of 0 to 1 to standardized format, so that all the variables are in the similar scale. And what it does, it removes the impact of scale, which is the unit of measurement. So how do you do it? You find the average of the data, you minus it and divide by the standard deviation. You should make a note of this. The reason is that you will have to use it later, because no way you like to present data in Z format, because nobody will understand it. And you can say, like if the variable is containing x1 and let's say Z value is coming as 0.6 and the mean of x was 150 and standard deviation was 250, you can say that actual value is like mean plus this mean plus Z into standard deviation, which is 0.6 into standard deviation, and that's how you get again 150 here, that makes it 300. So standardization means, let me just show you this standardization once again using Excel. So if this is the data that you have here, what you are going to do, you are taking the average and you are calculating the standard deviation, and then here x minus x bar, which is 13 minus this red, which is like the average, divided by the standard deviation, that is what is giving you the Z values. These Z values will always have that if you take the mean, it is going to be 0. In this is a small data set, that's why it has come 10 to the power minus 16, which is as good as 0, and standard deviation is going to happen 1. So the moment you have standardized all the variables, what has happened, that all the variables has now, all the Z values has mean 0 and standard deviation 1. In that case, all the variables, the scale does not make an impact.